Hello, I'm Dave Bennett. I'm with Phillips 66. And I was asked to speak on safety and security. My talk is a close relationship between cybersecurity and safety systems in the petrochemical environment. You can read this. The only thing I really want to point out here is I'm going to be talking about the 09, Technical Report 09, Cybersecurity Related to Functional Safety. I'll be referencing that in my talk. And it's got some good best practice. I know that people have asked where's some best practice for cybersecurity related to safety systems. I help write a piece of this on the metrics piece. There's also 8491. I'm not going to reference that, but there's a new standard coming out, and it's not just safety systems, but it's also all the independent protection layers that go around safety systems, help support safety systems. This API 2350 I'm not going to talk about, but I wanted to mention it. That standard is coming out. I'm on that. And this overfill protection for storage tanks, if you've seen some of the other talks, Bunsfield, Puerto Rico, those were all overfill of tanks. And this standard, I think you need to keep an eye out on. If you really want to reduce risk, start looking at where the accidents really occurred, right, and learn from that. So I would keep an eye out on API 2350. And if you're in Houston, this InfraGard, we meet monthly with the FBI. One of the best places for cybersecurity in our area, and we've got the best InfraGard section in the U.S., I believe, and we win awards for it. So, suggest you take a look at that. Okay. I'm really kind of working on a series of talks, and I see a need for this because when I talk to management, they really can't get a grasp on cybersecurity, and especially cybersecurity and safety systems. And so I've got a couple of other ones that I want to talk about in the future. That's about how safety systems are a cybersecurity defense. And then I wanted to talk about another reasons why safety systems needs to be independent. And I really think that's a lot. I like to say that's a pay me now or pay me later. I know one of the majors has talked about how they kept their safety system separate from their control system. And so they have a lot less lifecycle expense on cyber than those of us that have integrated safety systems with some of our control systems. And now we're getting to pay me later by adding more cybersecurity on top of our safety systems than some of our competitors that had kept that separate. So there's a life cycle cost there that we didn't think about in the beginning. The project people did. They integrated it because they could reduce their capital on their projects, right? But I think we're now kind of in a pay me later now that we have to think about cybersecurity and safety systems. I wanted to pause here a minute. I forgot to give a safety moment, and I think it's very relevant to this discussion. We do that, and I think it's goes along with safety. I had the radio on in my car the other day, and this announcer was talking about, you need our app, you need our app. You need to load our app and listen to us on the internet. And then all of a sudden, his voice change got a lot louder, and he said, if you have Alexa, just say, Alexa, load KABC app, confirm. I see a lot of you smiling now, and I thought to myself, how many Alexa actually, that voice was close enough to the voice that was in the house, and their app was loaded, and they didn't even know it. They didn't even know it. And if there's 10,000 people listening, maybe there were 50 that actually loaded. And I'm not sure that there wasn't somebody watching on the other end and saying, let's test this. How many can we get to load? I wish I knew that. So then in Houston, you have a little time to think while you're in the car. And so I thought, we're taking these phones and we're giving them to the operators because now our operators are mobile in our plant. And we've worked with IT to try to harden that, but we've given them this convenience. And that's the same way we did with what Alexa is. It's this convenience, right? And we feel like we've hardened it, but the unintended thing like Alexa, what are we not thinking about there? And that really relates to this 0-1 discussion that we're having here. They're now out next to our devices with this technology that maybe we thought of everything, maybe we didn't, right? I really don't know what's inside my Apple phone. It scares me. So that's my safety moment, and so the objective of this presentation, and Larry, keep me on track here. I can understand the close relationship of cybersecurity and safety instrumented systems, and my target for this discussion, when I looked at who was going to be in this forum, was really like IT managers. So I really crafted this presentation so that you might be able to take what I've talked about, modify it, and use it with your management as part of your speaking tools. So I'm trying to give you something applicable you could take back and modify and use. Please do. I'm going to talk about the new requirements. This is the first time I've seen in the petrochemical environment where there's now a shall for cybersecurity. You must do this, meaning you can be fined. Okay, so I'm going to be talking about that. And then the last one is, what can be done now to reduce safety and environmental cybersecurity at your site? So I'm going to try to give you some practical things to take back. We've heard since Monday, if it's not secure, it's not safe. And so that's really where I'm focused on today. And what Joe already kind of covered the Purdue model some. And if you don't know the Purdue model, go read about it. I'm not going to go over it. But what Joe's talking about is all of, this doesn't show very well, this whole level 0, level 1, all these controllers and instruments. What I'm talking about is about 20% of that in a typical refinery. In a typical refinery, 20% of your instrumentation is safety related, okay? And so the reason why I think this is so important is those of you that are justifying to spend money on your cybersecurity in the network environment, and you spend millions of dollars in the network environment, but you're not thinking about protecting your safety systems, and that's where you're attacked. I don't want to be the person that goes to the boardroom and say, well, I know you gave me all this money to protect cyber, but we didn't spend the money in this area also. So I'm not saying you shouldn't spend money on network cyber, but I'm saying if you aren't also considering specifically looking at your safety cyber, you may be in a bad position at some point in the future with your management, right? So don't go there. Okay. Sorry, I kept a few notes from going through the week that's not on here. So this is the applicable. So I'm going to be talking from a petrochemical environment. I'm going to go through a very simple model that you can explain safety, cybersecurity for safety and risk. And so that's what they're always asking. What's my risk? How do I relate it to my business, my other business risks? The other business risk that I know is going to happen. And Dave, you're saying this could happen, okay? So how do I relate that? Okay, so very simply, we're going to provide feed and heat to this boiler, to this vessel. We're going to boil oil. And when you boil oil, it creates light or gas. Let's just call it gas. And so this vessel pressures up. And there's three ways that this pressure is relieved in this vessel. One is the normal process. So if you're not used to reading these, I don't know if you can see this dot, it's kind of small. This is a normal way to relieve this pressure. It's through this control valve, through this pressure transmitter, and so these are all level 1 type stuff. You can't see the dot? Okay, so I'll just say CV1. That's the normal way that you relieve out of here. Thank you. And then if it doesn't relieve out that way, then there's a safety system, SIS3 there, and CV2, and that's the second way you can relieve. And then the third way you can relieve is a mechanical relief valve. And so if you're going through risk, and you can relate it to safety, that's what is the work group 9, the technical report 09 I was talking about. You can relate your risk that way. You can say, okay, someone, from a safety perspective, from a safety systems perspective, we always try to protect against failure of the basic process control system, PC1. It fails, valve goes closed. I've got my vessel is pressuring up. The second thing we do is we alarm the operator, PI2, PT2. Hey, operator, something's gone wrong. You need to relieve this, okay? And we know through statistics that the failure of this pressure control loop 1 is 1 in 10 years, so please follow the numbers with me. 1 in 10 years. We alarm the operator. 1 out of 10 times, he fails to solve the problem. So follow the numbers with me. What is that? What's my probability? 1 in 100, 1 in 100 years, right? 1 in 100 years, okay? So now now it's not solved. I'm expecting my safety system to open this relief. I know that the way I built this, it's 1 in 10 years, it will fail. So follow my numbers. It's 1 in 1,000 years that I now have to use the relief valve. And this is in dirty service, 1 in 10 years. So that's 1 in 10,000 years, this vessel will explode, and we will most likely have loss of life and environmental event, okay? So there's the scenario from a safety system perspective, okay? But you say 1 in 10,000 years, wow, that's pretty good, but I have 100 of these in the plant. Okay, now what did my number go back to? 1 in 100 years, right? So I'm hoping you're following this. Okay, I got some nods here. Good, I got some nods. Thank you. Give me a little feedback here. So, cybersecurity world, different. We have an event, and someone takes over our DCS system, our basic process control system. We lose 2 layers at the same time. Okay, different. Also, my numbers don't relate exactly, because 1 in 10 years was for generally having a failure from normal operator maintenance issues, right? This is not the case here. This was intended, right? So what's left is my safety system and my relief valve. Okay, if I have 100 of these in the plant, and someone takes over my DCS system, my basic process control system, I have a good chance that all of my safety systems have to work at the same event, on the same event. Okay? So if I have all of them having to work on the same event, what's my risk number? Kind of depends on the frequency that changed up here up on the top, right? So very important to spend money on your network. It helps reduce the frequency of this risk number. You have to determine what that risk number is currently by looking at your network and saying, how secure am I? But you can get to a number here on this scenario. And so what the new standard is, so you can get to a number here that you can relate to your risk matrix in your, for your company. And you can say, this is our risk related to cyber for safety and environmental events, right? Now, what's so important about that? You'll get funding for this. Why? It's safety, and it's a smaller number, and it's focused, and you can secure your safety system. After that, you've done what management's asked you to do begin with. The rest of the decision is mainly based on economics. You've kind of taken a lot of the safety out of this is an important point if you're talking to management. You've kind of taken the safety equation and not gotten rid of it, but minimized it by hardening your safety systems. And you've given them the ability to run their business. They can now make an economic decision on how much money they want to spend on cyber in the network, right? And that's what they're asking you. They're saying, let me run my business. Don't force me or pin me against the wall on something I don't understand, right? So key points from a safety system engineering perspective. Safety systems is designed to protect against the basic process control system. That's our mission. That's what we've been doing for years and years and years, more years than I can count. There's no difference from a safety instrumented system engineer's perspective on whether it failed from operating and maintenance failure or whether it failed from a cyber event, except intent and demand rate. And who can know the mind of a man? You know, intent is something you may never know. Demand rate, though, is you can take that from the numbers I just went over. You've got to do it for your own scenario. And this is why safety systems and mechanical systems like relief valves are cybersecurity layers that we should never allow to be infiltrated. It should be the inner sanctum of our systems. I'm not going to read this, but this is the new section 824 inside of the Safety Instrumented System Standard that has the shall in it. A security assessment shall be carried out for security vulnerabilities. And there's not as much teeth in it as I would have hoped. You've got to do the security risk assessment, depending on how long you want to take to resolve what you find. You know, that's kind of flexible to you, and that's okay because you got other business things that are competing for money. But I want to talk about this for a second. Let's see. Third from the bottom dot point. Considerations of life cycle for safety systems include design, implementation, commissioning, operations, and maintenance. So this isn't just, this is your EPCs, your MACs, the design part. You have shalls now too. It's not just the user. You have some requirements that you've got to show when you did the project and you did the design. You had a security assessment that was done, right? So it is not just the users anymore. I think that's all I wanted to cover here. Let me catch up real quick. Yeah, good. Okay. So this is the technical report I've been pointing to. 100 and some odd pages. I think this has got some really good guidance in it. Section 5 and 6 is how to do a cybersecurity risk assessment. So that's the how part of the what I just gave you earlier. Some guidance there. I think Annex A and Annex B in this document are very relevant to provide a quick assessment. Annex A, you can take your safety instrument assisted architecture and compare it to typicals inside NXA, and it gives you what the common vectors are for that, and it gives you the common mitigations for that. And I like to say about cybersecurity, it's like running from a bear. You just don't need to be the last one. And as long as you're in the pack, and you're probably not going to be the one that gets caught by the bear. No relation to, well, bears have, anyway. So what you'll find if you do, so this is an example. So here's an architecture that someone had, and they looked at the before and after of the architecture, and this was a recommendation inside the technical report based on the targets, the vectors, and the mitigation. I'm not necessarily saying you got to put firewalls on every one of your safety systems. It depends, right? It depends on your assessment, right? This is going to lead into the next discussion. I wanted to talk about TRITON for a minute. That's what I call it. So the recommendations, these are the recommendations. You can read those. I'm not going to go through all of those. But the important part, if you build your safety system right, half of these are physical. Half of the recommendations are physical. If you can keep somebody's hands off of your safety systems, and if you're managing how you attach to your safety systems, you've covered half the mitigations here, right? You need to be in isolated networks. Talk about operator stations and common things like the program mode, and then the enhanced security features that they're recommending you to turn on. But for me, when I go into a plant and I assess all of our refineries, when you go in, the first thing I look at is how they're managing around their safety system, physical, and how they're managing their engineering station, how they're managing the box, how they're managing updates on their cyber protection of their box. Those are the things I'm really looking at, because that's 80% of the answer to safety systems. So here's my summary slide. Safety systems are designed and operated and maintained to protect people and the environment. Safety systems are inherently a cybersecurity layer of protection. I'm probably going to make a set of slides on that in the future. It's important for safety systems to be independent. I mentioned about the pay me now or pay me later. I think if once we start understanding the life cycle costs of cyber in people, in contracts, we're going to realize how much it really costs for the life cycle of a safety of cyber, and we're going to be some of the competitors of ours. I work closely with them on some of these standards. They're actually going back to some analog safety systems in remote areas, especially like skids, things like that. They're going to analog. What does that mean? It's a trip amp, and you have to change the set point trip. It's a screwdriver. As long as you've just reduced the vectors by a lot, your cybersecurity lifecycle cost is a lot lower. But that applies some places, right? That's not like you would apply it everywhere. I reviewed the shall statement with you. I think if you need to look at that, you need to start putting it in your business plan. And gave examples of what you can do now. And I really point out the Appendix A and Appendix B as guidance for meeting the standard. I think it's very applicable. That's all I had.